Chapter 4, Section 1 is all about quadratic functions and transformations. And today we'll talk about how we can transform quadratics and what they look like generally. So just a quick reminder on transformations of the parent function. Remember that insides move opposite left, right. Outsides are normal, up and down. You can also reflect it, stretch, and compress it. So letter A, that -1 on the outside, moves your graph down 1. In letter B, you have two movements. The first one I'll talk about is the down one, because that's the one that's probably easier for you to handle. But that minus out front is a reflection. And because that minus out front is outside, it's an x-axis reflection. I'm going to start writing R with a circle around it for reflection, just as a shortcut, but keep in mind it's a reflection of the x-axis. In letter C, that +3 on the end moves it up 3. In letter D, I see a reflection on the x-axis and an up 3. In letter E, the +1 inside moves it left 1, the +4 outside moves it up 4. And in letter F, I have a reflection in the x-axis because of the negative out front. I have a left 1 because of the +1 inside, and an up 4 because of the +4 outside. These transformations are not any different than you did in Chapter 2, Section 6. Pause the video to complete the You Try It. So we're going to talk about a quadratic function and a parabola. A quadratic function is any function whose highest power of x is 2. So if the largest number you have in the air is a 2, that's called a quadratic. Anything that's an x squared is basically what we're talking about. When you graph that quadratic, it makes a U-shaped graph, which is called a parabola. So there are a whole bunch of natural places that we can see parabolas, and you can see a couple pictures there. That upper left-hand corner is an underground water tunnel. On the upper right-hand corner, that's one of the arches of a church. Then on the bottom left, you have a bucket of water being thrown at somebody. That creates a parabola naturally as the water goes up and then arches back down. And then in the lower right-hand corner, there is a bridge, a suspension system for a bridge. So these are common places that you can see parabolas or U-shaped figures that happen outside of the math classroom. So this is a do you remember? This is basically a line. If you take a look, y equals 3x minus 1 is just a linear function. But I want to remind you of what it's like to make an XY chart for anything. So remember, when you make an XY chart, you tend to pick a negative, 0, and a positive. And one by one, you put those values in for x to get y values back out. So I'll show you where that -1 goes in the first one. If I put a -1 in the spot for x and evaluate, 3 times -1 is -3, and -3 minus 1 is -4. So I won't show you the other two because they're kind of straightforward, but if you put a 0 in for x, 3 times 0 is 0, minus 1 is -1. And 1 times 3 is 3, minus 1 is 2. And that XY chart become ordered pairs that you can plot. -1, -4 is there in quadrant 3. 0, -1 is right on the y-axis, and 1, 2 is in quadrant 1. This is how you first learn to graph. Then you would connect them using a straight edge. It's a line. And since then, you've gotten shortcuts, like you know y equals 3x minus 1. That -1 at the end is the y-intercept, and from there you can count out the slope. It's the same graph. But this making an XY chart is kind of a fallback method that you can choose, that you can use if you don't know how to graph it any other way. So we're going to start that way when making these U-shaped graphs. If you recall back in Chapter 2 when we first looked at graphing a parabola, I had said to you then, you're not quite sure how wide or narrow the top of it is. All you know is where this starts. And this is how we're going to get the width at the top. We're going to make an XY chart. Now, I do want to point out, if you take a look at letter A, you should at this point know it hasn't moved left, right, up, or down, but it has been stretched. So I should expect relatively a skinny graph. So pick values of x to plug in to get back out. So I'm going to pick -1, 0, and 1. And I'll show you for the first one at least. If you put a -1 in, make sure you put parentheses around the x before you square it. If not, the calculator won't perform order of operations correctly and you'll get the wrong answer. So -1 squared is 1, times 2 is 2. If I plug a 0 in, 0 squared is 0, times 2 is still 0. And if I plug a 1, 1 squared is 1, times 2 is 2. So plot those points. -1, 2 is right there, 0, 0 is there, and 1, 2 is there. Now be really careful when you draw these in. You don't want to have it be a V-shaped graph. You want it to be a U-shaped graph, a parabola. So it should be curved at the bottom. Those ordered pairs make sense. It does look pretty skinny, although looking at letter B when we're done will help us. But it hasn't moved left, right, up, or down, so its change of direction is sitting on the origin, which is what we'd expect. Now you're always going to pick values of x to get values of y back out, but make them wise choices. Like in letter B, if I pick -1, 0, and 1, I'm going to end up with fractions. So instead, based on the fact that this denominator is a 3, I'm going to pick -3, 0, and 3. If you plug a -3 in, -3 squared is 9, times 3 is 3. Putting a 0 in, 0 squared is 0, times 1/3 is 0. And plugging a 3. 3 squared is 9, times 1/3 is 3. For the most part, this number and this number will match. And that's not always, for sure, but for right now, they will. So if I plot those points, -3, 3 is here, and 0, 0 is here, and 3, 3 is here. So you'll notice when you draw this one in, still a U-shaped graph, it's considerably wider than letter A, which is what we anticipated because it is a compression and not a stretch. So in continuing with picking those smarter choices, in letter C, because the denominator is a 3, I'm going to choose -3, 0, and 3. Try to stick with the negative, 0, and positive, although you'll see a little bit later on that those choices aren't necessarily where we want to go. So if we plug a -3 in, -3 squared in parentheses, don't forget parentheses, -3 squared is 9, times a 2/3 is 6. If I plug a 0 in, you're going to get a 0 back out. And if you plug a 3 in, 3 squared is 9, times 2/3 is also 6. So -3, 6, I'm kind of going to cheat a little bit because that's off the grid. And 0, 0, and +3, 6. And then connect them. It's a little more V-ish than I'd like. I should probably just fix that quick. A little bit better. All right, letter D. Because that denominator is a 2, I'm going to choose -2, 0, and 2. If you plug a -2 in, -2 squared is 4, times a -1/2 is -2. If you plug a 0 in, 0 squared is 0, times a -1/2 is 0. And if you plug a 2 in, 2 squared is 4, times a -1/2 is -2. So -2, -2 is in quadrant 3, 0, 0 is the origin, and 2, -2 is in quadrant 4. So this graph kind of looks like it goes upside down. But take a second and consider whether that makes sense or not. This graph has a negative out front, which we talked about earlier as a reflection. Reflections are going to take your U-shaped parabola and turn it upside down. It's going to be an upside down U because you're flipping it over the x-axis. So anytime you have a negative out front, expect it to open down and not up. Pause the video to do the U-try-its.